Hello student. In this session, I will try to introduce you guys about a quick introduction to how to run the K-mean cluster on Excel. Actually, when you do for the customer settlement or the other K-mean cluster algorithm, normally people use another tool like RabbitMiner, Python, or R. However, actually you can do it very easily on Excel if you really want to do that. And today's section we will learn how to just run for the K-mean cluster for two simple examples. The first of all, we use the Euclidean distance, and the second one will be use the Manhattan distance. So K-mean cluster will be basically the idea when you first of all choose an initial centroid or the centers of its cluster. For example, here we want to just have a three different clusters, so you choose like three different centroid. Later, you measure the distance between all the other the other data point into the initial centroid, and you see like which one will belong to how far from the centroid and which one will belong to which centroid which cluster. Later, if you feel it's not so good about the initial centroid, you will have to recalculate the new centroid, and then one more time you repeat the previous state, like measure the distance from all the other data points to the new centroid, and you finally just go and repeat the iteration until when you feel like all of them has been clustered into the real cluster. Basically, we have two different ways to measure for the distance. The Euclidean distance, which you can see this could be just the square root of all the squares of the distance between the different coordinates between x and y, the thing like that. And the second way would be like Manhattan, actually just the sum of all the kind of like absolute distance. Okay. So we will try to just demonstrate that in the two sample. Okay, there's two example, and for the first one, I'm going to use the example of the 7 data point A, B, C, D, E, F, G with this coordination from x and y, right? And we will try to just create the two cluster from the point that I kept given. We use the Euclidean distance and use the initial centroid like C and G. Okay, so with this one, I will choose first of all choose for the initial centroid. Okay, one, and the second one initial centroid 2. Okay, and let's first choose it's like be C, right? Sorry, this will be C. Okay, and this will be G. Okay, I can choose this one. I can move this one a little bit up ahead. Okay, and I make this one to this much. Okay, all right, and now this will be initial centroid, and the thing we're going to just do with will be like how we have to measure the distance. Okay, the distance between all this data point into their Euclidean to the initial centroid. So I first of all create for first of all we have to remember that we need to create two cluster. Okay, and this will be the cluster. I would just make it into merge this one and then power it. Okay, and I first of all has to calculate the distance to centroid 1, and second will be the distance to centroid 2. Okay, and the last one I will have to know that each data point belong to which cluster. Okay, to which cluster. Okay, so with the data point from 1 into 7, let's first of all check this. So Euclidean distance, remember this will be just the square root of all the total of all the square of the distance. So we first of all have to measure the distance to the centroid number 1, right? So for example, data point A. Okay, first data point or data point A, that will be what? First of all, we measure for the all the square of the distance. Okay, sorry, equal to the square of distance. So this one will be the coordinate of x minus 4 the centroid 1 coordinate of x, and then we square it up, right? And then we plot with the centroid, initial centroid of the coordinate of y, okay, the data point A, coordinate y, and minus 4 the initial centroid coordinate y, okay, and then we square it up. So actually this could be the square of the all the distance, but we also need for the square root, right? So we use the function sqrt. That should be the square root, and that's what we got from the distance centroid 1. Okay, the reason why I put it here could be like all the dollar sign would be I want to fit the two the two cell, okay, and with that way I can easily just drop this formula into the end, so I don't have to repeat for this one more time. Remember here, because I choose the C will be the initial centroid, okay, so the distance from the data point C or data point number 3, right, to each cell will be totally 0, okay. And one more time I repeat this one by the I see the distance between the all the data point into initial centroid B, centroid 2. So I one more time use of repeat for all the function number 2 again. Sorry. Okay, so equal to initial to the coordinates x of the data point A minus 4 coordinate x of the data point initial centroid B, and then we square it up, and when we plot for the same thing, we minus 4 the initial centroid B, okay, sorry, and then we square it up, okay. Of course, don't forget to use the square root for all the data. Okay, so this will be this point, and we can see this will be the initial initial data. Okay, so now based on the distance between the data point into the centroid, so we can determine which one will belong to which cluster. Okay, so for example, for the first data point 1, right, we see like it's closer to the centroid 1 than the centroid 2, so it should belong to the cluster 1, right? Okay, on another side, let's check. Okay, so for example, in the data point 5, okay, we see like this closer to the centroid 2 compared to the centroid 1, so it should belong to the cluster 2. Okay, we can do this manually, but however, if we do that, that's quite a tedious, right? Because in some case we have a much more data point than that, so we don't have to do that. We just use a function. Okay, so I use function if this one smaller than this one, okay, distance to the centroid 1 smaller than distance to centroid 2, so it will belong to the first group. Okay, if not, it belongs to the second group. And ta-da, we can do it, and that's make quite a good, right? Okay, so this is our kind of like the iteration 1, or you can say the first trial. Okay, the first trial of the calculation, and you can copy all this data. Okay, copy all this data, and then you can basis is here. You can go and paste spatial, and remember to choose like just the values. Okay, not just the formula, because it's after the second iteration, or then we mess up. So that should be my point. Now until this point, you can see like the data point 1, 2, 3, and 4, right? A, B, C, D, right? They have belong to the first cluster, and the rest belong to the second cluster. So this will be the time for me to change for the initial centroid. Okay, so what will be the initial centroid now? I will choose this one will be the average of all this data point A, B, C, D, because they all belong to the cluster 1, right? So the centroid, new centroid, must be in the central of this data point. Okay, so I will use the function average and get all the average values of this coordinates of x for all the 4 data point. And the same thing, right? If I drop it here, that's going to be the coordinate y, okay? The same thing with the initial centroid 2. So I use the function average of this point because they belong to the second cluster, okay? And this one. Okay, so this could be the new centroid, and this will be the new data. So we see like now the thing has been changed a little bit. They believe that with the second iteration, this first data point, okay, data point A, now is will belong to the cluster 1, and the same with the data point 1, 2, 3, and the rest 4, 5, 6, 7 they belong to the cluster number 2. Okay, so it's clear that everything has been changed after the second calculation. So I will one more time paste this here, but I will say this will be the second cluster. Remember to just save it, or to just we do it for the kind of reference for the next trial. Okay, and now with this one, it's no longer this 4 point, right? This could be just the data point 1, 2, and 3. So this could be the 3 data point. Okay, this 3 data point will belong to. That's what we are doing. So now I use the average function one more time and calculate for the new centroid. Yeah, I will just clean this one. Okay, I just clean this one. Okay, and then now have to recalculate for the new centroid because now the cluster has moved, right? So I choose for average one more time and choose for the cluster of all the things belong to the cluster number 1. Okay, and this will be the new centroid, and the same thing. So average of this one and this one. Okay, so so this will be the new centroid, and for the third time, okay, for the third term of iteration, for the third term of iteration, okay, iteration number 3, let's go and check, see like what will be the result. Okay, so this, oh, I'm sorry, because this one I didn't just copy it, but they just the values only. Okay, I put in just the value only. And the third term, you see like 1, 2, and 3. They are one more time become like they belong to the first cluster, and the same with this one, right? With the first cluster, 4, 5, and 6, and 7 they belong to the second cluster, and this one second cluster. So that means it didn't move. Okay, it didn't move. And what it means actually? So if I really go and do the measure for one more time, again, A, B, C, D, or 1, 2, 3, the data point will be one more time just the data point belong to cluster 1. And if I one more time measure for the average, right, the measure for the average, so they be one more time just the same with what I already measured before. And this one average of all the kind like 4, 5, 6, 7, they is the same with the previous calculation. And that means now the cluster no longer move, and until this point I can say like the same result. Okay, we got the same result with the second trial. What does mean? The cluster do not move anymore. Okay, and that means it's stable, and we can stop it here and we can make conclusions. Cluster number 1 and cluster number 2. So cluster number 1 will be 1, 2, 3. Okay, cluster number 2 will be 4, 5, 6, and 7. This will be the data point A, B, C, D. Okay, so we can see them will be like going this way. Okay, so that will be the initial example, and we do it with the Euclidean distance. Okay, when we measure it based on the square root of all the square of the distance. Now let's try it one more time with the Irish flower, which will be one of the things more like practical and closer to our example. So in this one, we have 2 clusters for all the different characteristics of the flower. Okay, including like the 7 length, the 7 width, the petal length and the petal width. And with this one, we have to measure and see like which one belong to which cluster. Okay, so with the same thing, I would going to just do it. We will like I'm going to just use for the initial cluster. I want to just measure for all the thing the same. Okay, and I want to get the initial cluster. So it totally is up to you. Actually, it totally is up to you about which cluster you want to just get the initial. Okay, sorry, it should be this one. Okay, so I would choose like the data point number 3 and data point number 6, like the initial cluster as a centroid. You just start for all the calculation. Okay, and now the same thing I'm going to just measure for that one, and I do it very quick. The only thing different will be now we use the Manhattan distance to just travel and see for the distance between the data point and the centroid. So to do that, I'm using the function ABS. Okay, the absolute values of the distance between the centroid length and the separate length of the initial centroid. And I just fit this one like what I did before, right? ABS and the same now with the separate width, and then I got the distance to the initial centroid, but I fit this one. Okay, I plus for ABS one more time, absolute values of the pencil length of the first data point, and then the initial centroid pencil length, and the same. And I ABS one more time between the pencil width and the initial centroid width, pencil width. So this will be their total distance based on the Manhattan distance. Okay. In this one, they just show you in the just like 2-dimension coordination, but here we have the 4-dimension coordination, and you just apply the same with the 5, 6, 7, or maybe 10, or maybe 100 dimension, the same. Okay, so I choose this one, and I can measure the distance from the data point into the first initial centroid. The same thing I'm going to just use and do it very quick. Okay. See the distance to the second centroid, and this one I think like you will feel like it's quite easy now. ABS, and then this one minus for this one. Okay, ABS, this one minus for the initial centroid second dimension. Okay, and ABS the same. Okay, so that's it. Alright, and we use the function if, right, to see like which one will belong to which cluster. So the same, if this one smaller than this one, so this data point belong to the first cluster. If not, they belong to the second cluster. Okay, and I close this one. So this one, right, 6.7 compared to 6.9, this one very close to the cluster, to the central 1 than the central 2. So they belong to the first cluster. For this one, they should belong to the second cluster, right? Because of the distance to the centroid 2 is closer. And the same thing we apply for the same philosophy for the rest of that. Okay, so we're done with the first iteration. Yeah, I'm sorry, one more time. Do it, pay special, and this will be the iteration number 1. You can say that the first trial. Okay, and let's I'm sorry. Let's just move it down here. Okay, that's okay. Right, so with the initial central, okay, with the initial central, we got this one. Now let's try it with the second iteration. So when now we can see like first data points, the third and the fourth data point, they belong to the first cluster. Okay, so this will be the way for me to just one more time calculate for the initial centroid. So I do for the average one more time, and with this one, and this one. So I measure for the new centroid data point. Okay, and the same thing that I apply for the rest of that. The same thing. Now the average of this data point belong to the cluster 2. So this will be 2, 5, and 6, right? 2, 5, and number 6. Okay, so this is the new centroid. Okay, so with this one now we can measure that, and we see that the centroid and the cluster has been changed too, right? They move for one more time, and now just 1 and 2 belong to the cluster 1, 3, 4, 5, and 6 belong to the second cluster. Okay, let's just keep it here and save it to just a spatial and save it. Okay, if you want to just move this one a little bit inward. Okay, a little bit inward. Okay, iteration 2 and the second trial. Let's do it with the third trial. Okay, so with this one now, no longer this will be 1, 3, 4, but just like 1, 2 will belong to the first cluster, and let's do it with the second, with the next iteration. So let's do average one more time, and let's change the new cluster centroid into this point. Alright, and the same thing now, the average of the 3, 4, and 5, and 6, right? So 3, 4, 5, 6 doesn't belong to the second cluster. Okay, so we have this one, this will be the new cluster. Okay, and I just copy it here, a spatial. Okay, and this will be the test cluster 3 and okay. So the same thing, we see that until this point, that will be 1 and 2 will belong to the cluster number 1, right? And 2 and 3, 4, 5 will belong to the cluster number 2, and that's have been repeated. So that means, yeah, the data now, the result has been the same with the second cluster, the trial. So that means the cluster do not move anymore, and we can clarify that the cluster number 1 will be the 2 data point 1 and 2, while the cluster number 2 will belong to the data point 4, 5, 3, 4, 5, and 6. Okay, yeah, so that's we have done with the way for it to just demonstrate about you guys how to just run for the cluster by the two different distance methods, distance thing by the Euclidean and also for the Manhattan distance. And you can see that the same thing will be applied on rabbit miner when they do it with the data point of the with the other data point of the iris full flower data set. So this will be just the initial introduction and the demonstration for you guys to how all the kind of algorithm work. Actually, they're much more complicated and more kind of optimal algorithm has been developed for the K-mean cluster. But let's first just start here. And thank you so much for your attendance, and see you later in the next video.